some, we have here the K-mapping steps example, wherein we have the given inputs A, B, C, and D, and one of the outputs that is the small letter A. So the first two steps will be evaluate the number of inputs and draw the grid. So in this case, A, B, C, and D, there are 4 inputs, which means we will have a 2 by 2 matrix in the grid, wherein the 2 corresponds to the rows A and B, which has, so 2 raised to 2, that will be 4, which will give us 4 possible values, 0, 0, 0, 1, 1, 0, and 1, 1. We also have the column, the number of columns, so that means 2 raised to 2, that is 4, which has values 0, 0, 0, 1, 1, 0, and 1, 1 for the C and D inputs. For steps 3 and 4, so make the input and map the input and output values. So from the given truth table, let's have an example from 0, 0, A and B, so to be mapped to the grid. On the row part, we have A and B, that is 0, 0. And for the column part, we have 1, 1 for C and CD. And the intersection of the 0, 0, 1, 1 gives us an output 1, which is mapped in the cell of the grid. Another example will be 0, 1, which is the row 0, 1 for AB, and column 1, 0 for CD. Its intersection is the cell for the output, which is 1. For another row 1, 0, which can be found at the bottom part of the grid due to the gray coding. So 1, 0 and 0, 1, the column part, 0, 1 for the CD, its intersection gives an output of 1, which is the value in the cell. And lastly, we have 1, 1, okay, and 0, 0 for the column. The intersection has the cell value that is equal to X. So as you can see, the different values here in the gray code. So from 0, 0, 0, 1, there's only one bit changed, which is from 0 to 1. And the next bit, the next transition will be 0, 1. So 1 remains 1. However, there's a transition from 0 to 1. And the next transition will also be another bit, one bit changed, which is the B bit from 1 to 0. So same goes with the CD column. So from 0, from D is equal to 0 to D is equal to 1. So at this particular pair, it has only one bit to change. Thus, you have 0 to 1. And then lastly, this particular transition, there's only one bit change, which is the D from 1 to 0. So after we've already mapped the input and the output from the truth table to the grid of our KMAP, we will now proceed to the next step, which is to group the, depending on the function. So the group, if that is SOP, we will be grouping values 1 by 2s, by 4s, or by 8s. If we will be using function product of sum, so which means we will be grouping zeros by 2s, by 4s, or by 8s. So for this given example, since our output is 1, so we are considering the 1 output, so we will be using